Hey guys, okay, we are starting Unit 14 of our textbook that honestly, in a lot of other textbooks and areas, you are going to see hormones as well as homeostasis embedded into your coordination and response unit. But our textbook splits it up. And I think this is honestly a better way because if you think back to your coordination and response unit that we just covered, it's fairly extensive. So having more information, I think, was a little bit overwhelming for sure. So we're going to call this Unit 14, Hormones and Homeostasis. However, it does have a little bit of overlap with coordination and response that we just covered, but we're coming off of it fresh, so you should remember some of the terms and information fairly easily. So to get right into it, let's talk about what is a hormone. A hormone is a chemical substance produced by a gland and carried by the blood, which will alter the activity of one or more specific target organs. So these are going to be chemicals which transmit information. So in the coordination and response unit, we were looking at electrical impulses and how they caused some sort of effect in our body. This is dealing with a chemical transmitter of information for the body to bring about some sort of change. Now, the glands that produce these hormones are known collectively as the endocrine system, and there's several glands that we'll look at in the next image in just a second. And then endocrine glands, just to note, have a great blood supply because, again, all of these hormones have to travel in the blood, as well as just being able to be created as soon as possible and be able to travel to those target organs and bring about the response. Blood supply is key. And it's also important to note that once a hormone's been used, the liver is going to take care of destroying that hormone and excreting it for you. All right, so let's go ahead and look at the endocrine system as a whole. The glands involved with our endocrine system, the pituitary gland, which is like your master gland in your brain. It's situated at the base of your brain and really controls all the rest of the hormones in your body. The thyroid gland, it produces thyroxine. You have your pancreas that produces insulin that we'll look at in the next couple sections when we start talking about blood glucose and homeostasis with our glucose levels in the blood. The adrenal glands produce adrenaline, which many of you have probably heard of. And then oops, my phone's ringing. One second. Okay. Back to it. I believe we were at the testes, which produce testosterone for the male sex hormone. And then, of course, in this diagram, it would be indicative of a male. So we also need to make sure we don't forget the female. She has ovaries to produce estrogen, which is the female sex hormone. The pancreas produces hormones to regulate blood glucose levels as well as digestive enzymes such as pancreatic amylase and lipase. So it's important to note the pancreas does a lot of important things. So it's not just the insulin producer. It has some roles in the digestive system, which you might remember from Unit 7. When we're looking at all of these glands, just remember great blood supply, great blood flow to all of these glands because these hormones have to travel through the bloodstream. Now, it's also important to note that hormones affect cells with target receptors because remember, they're still in this realm of coordination and response because the pituitary gland in your brain is triggering the different glands to produce hormones to travel through the bloodstream to the target areas of where they will be affected. Now, if you think back to that coordination and response unit, we had muscles as glands as our effectors. So when you're looking at this, it can be depicted in this nice little diagram here. Let's just say your pancreatic gland cells are going to produce these hormones that are specific to a target cell receptor that's complementary to the hormone where it needs to be used. Now, if there are other cells in the body that have different receptors, it's not going to make the fit. So if it doesn't fit, it won't be received. It cannot be used and processed. So Hormones are incredibly intricate and unique. That's kind of a very quick flyover of that information. But this table will also be something that you really need to focus on. It is going to be provided for you in your notes, but the 4 hormones that we're really going to look at for this unit is going to be adrenaline, insulin, testosterone, and estrogen. Now, for adrenaline, like I said earlier, this is produced in the adrenal gland, and it readies the body for a fight or flight response. It increases heart rate, breathing rate, dilates the pupils. Ultimately, adrenaline is what we naturally create to really help us with survival, especially if any of us ever find ourselves in circumstances where we need adrenaline to make a quick decision on how to handle something. Insulin. Insulin's also another one that we're kind of going to circle back to, like I said earlier, in looking at how the body regulates our blood glucose level. Created in the pancreas, it causes excessive glucose in the blood to be taken up by the muscles and liver. And then at the liver, it's converted into glycogen for storage, which is incredibly important. This insulin, which we'll talk about a little bit later, is what type 1 diabetics struggle to create. And then if you're a type 2 diabetic as well, which can be managed, but type 1 is something like you're born with. So we'll discuss that in the next couple sections. Testosterone and estrogen we'll also get to revisit when we do our unit on human sexual reproduction. But important to note, testosterone produced in the testes, estrogen produced in the ovaries. Testosterone is your main sex hormone in males and helps with the development of secondary sex characteristics in males. And estrogen is produced in the ovaries. It's the main sex hormone in females, which helps the development of secondary sexual characteristics in females and controls the menstrual cycle. And again, this little table, very important, will be provided in your notes. Another quick note about adrenaline, kind of like I mentioned earlier, produced in situations where the body may be in danger. So the reason why it would be really helpful for us to increase the respiration rate is so we can increase blood glucose in our muscle cells if we need to act quickly. It helps to increase pulse rate, which helps increase breathing rate so we can have more oxygen and glucose delivered to all the muscle cells in our body. To have some sort of quick response if needed. It also can help with diverting blood flow towards certain muscles. So, if you, depending on what type of response is needed, it can divert more blood flow towards the muscles where they would be targeted. And then, of course, dilating your pupils to allow in as much light as possible to reach the retina so more information can be sent to your brain. So taking it all in remember, our eye is a receptor. And this is a great table. Again, it will be provided in your notes. It just really talks about the comparing of our nervous control system to our hormone control system. When we're looking at the type of messages, for our nervous system, that's the electrical impulse that travels somewhere along nerves, the brain, and spinal cord. Remember your reflex arc. And then for the endocrine system, this is made up of your glands. So all those glands that we looked at a few minutes ago. And the type of messages that are sent are chemical hormones, okay? The speed of transmission for your nervous system, incredibly fast, very quick. Most times we don't even know things are happening. They're happening so fast. For the endocrine system, very, very slow. So just to note the difference there. And then the length of the effect for our nervous system, the effects are very short until nerve impulses stop. So things are very quick, but they're very short. And then for the endocrine system, the length of the effect is very long or until the hormone is broken down. So the reaction continues over a long amount of time and it's slower. All right. I think that wraps it up for this first section on hormones. Definitely head on over to your notes and your diagrams, get all those logged in, take your CFU, and then any activities that we have for the day, guys. Proud of y'all. Have a good one.